All right, so on this homework, I'm going to do the first 7, I think, in this video, and then I'll just come back and do some other ones. So in question 1, right, we're just taking a limit, and one of the first things we should always think of is just plugging in the value, right, direct substitution. So if I do that here, we get 3 times 5 plus 1 over 2 times 5 minus 6. Right, so that's going to give us 16 over 4, so this should just be 4. Right, so if I look at question 2, same idea. Let's just try direct substitution first. I'd get 2 raised to the 3rd power minus 3 times 3. That's going to be 8 minus 9, so this should be negative 1. If I look at question 3, I have this same thing. Let's try direct substitution. So if I did the sine of pi over 4, break them unit circles out, that's a radical 2 over 2. So this limit is simply radical 2 over 2. If I went to question number 4, here we get a little bit of an issue, right? Because if I plug in negative 3, I get negative 3 squared minus 9 over negative 3 plus 3. And oh no, we get a 0 over 0. So we get an indeterminate form. Couple of things we could do. So one thing we could do is that many times before we even knew L'Hopital's rule was a thing, we would do algebraic simplification. So I could take this top and I could say that I have the limit as x approaches negative 3 of factoring x plus 3, x minus 3, and in the denominator, x plus 3. Now where x plus 3's cancel out, which cancels out the problem in my denominator, aka it creates a hole at negative 3, and as we undoubtedly know, limits exist at holes. All right, so if I took the limit as x approaches negative 3 of now x minus 3, that simply gives us negative 3 minus 3, which is negative 6. Now, you're more than welcome to use L'Hopital's rule if you want as well. So to do that, since we have an indeterminate form, and only because we have an indeterminate form of 0 over 0, we could take the derivative of the top. So we have the limit as x approaches negative 3. Limit of the top is 2x. Derivative of the top, my bad. And derivative of the bottom, which is just 1. Now, again, notice that we've gotten rid of the 0 problem in the denominator. When we plug in negative 3, we simply get negative 6 again through direct substitution. If we looked at question 5, if I did direct substitution, I'm going to get the cosine of 0, which is 1, over 0 plus 1. So that's just 1 over 1, so this limit is 1. In question 6, same idea. Let's do some direct substitution. E to the 0 plus 3. That's 1 plus 3. So this thing's going to be 4. If I looked at question 7, let me do some direct substitution. I'm going to plug in a 1. I'm going to get the natural log of 1, which we know is 0, over x to the x. Well, 1 raised to the 1, which is just 1. So this limit is 0. If I did question 8, I know I said I was going to go to question 7. I went to question 8. I gave you a bonus question in this video. Same thing, we could just plug in 7 pi over 4. And the tangent of 7 pi over 4, again, you could think about unit circles, or you can just hopefully know these values. This is in the 4th quadrant. It's a pi over 4. So tangent of pi over 4s are always 1s. It's just positive or negative. Since we're in quadrant 4, where tangent is negative, this would be a negative 1. All right, so I'm going to come back. What do we got? 21. I'll go to 11 here. I'll go to 11. We'll split it half and half. So we would have as x approaches 0, we have the secant of 0 times e to the sine of 0. Right, so the secant of 0, just in case you forget, is 1 over the cosine of 0, which is 1. E to the sine of 0. Sine of 0 is 0. So this is like e to the 0, which is also 1. So this thing would be a limit of 1. If we went to 10, if we plugged in a 12, we're going to get an issue here. Right, so if I plug in a 12, I'm going to get the square root of 9 minus 3. I was still trying to find the pause button. Suppose you hear me choke on microphone. So that gives us 0 over 0. So we have an indeterminate form. So a couple of things we could do. Number one, we could also do L'Hopital's rule. If we did L'Hopital's rule, I don't know why I wrote a weird H, we would take the derivative on the top. So the derivative of x minus 3 minus 3 would be 1 over 2 x minus 3. Right? No chain rule really needed because the derivative of x minus 3 is simply 1. The derivative of negative 3 is 0. The derivative of x minus 12 is 1. So then I would get 1 over 2, 12 minus 3. So this is just going to be 1/6. That would be one way of doing it. Another way of doing this limit would be multiplying the top by the conjugate. So if I have x minus 3 over x minus 12, the bigger problem here is the radical x minus 3 in the top, less so the x minus 12 in the bottom. So if I multiply the top by radical x minus 3 plus 3, I'd have to do the same thing in the bottom. So I get radical x minus 3 plus 3. If I expand this out in the numerator, right, I'm going to get a difference of squares. So radical x minus 3 times x minus 3 is going to be x minus 3. And then we're going to get a minus 9. And then those middle terms, right, this negative 3, that's not a highlighter, this negative 3 times the radical x minus 3, and this outer term, this positive 3 and this radical x minus 3, they just cancel out, right? We get a difference of squares. One of the main things, if you do these kind of algebraic manipulations enough, is you know that you don't want to go multiplying out the denominator. That kind of sucks and it makes it more difficult. So, like magic, our numerator becomes x minus 12, which we still have with this x minus 12 in the denominator. So here's where our cancellation comes in. Here's where we get rid of that problem 0 in the denominator. So we get these cancellations. Cancel, cancel. And now when I plug in that 12, I get 1 over the square root of 9 plus 3, which gives us the same 1/6 that we got before. All right, and then the last one for this video, tune in for the next series, would be the limit of sine of 5x over x. All right, so this looks a lot like the limit of, as x approaches 0, of the sine of x over x, which we know is equal to 1. So if we were being like super duper like math nerds, we would say to ourselves, well, I can multiply the top and bottom by anything that I want. So I can multiply the top and the bottom by 1 over 5x. This would then be the limit as x approaches 0 of the sine of 5x over 5x over x over 5x. And this is going to simplify a lot now. This is going to be x over 5x. We get 1/5 in the denominator. If you divide by 1/5, that's the same as multiplying by 5. So we're going to get 5 times the limit as x approaches 0 of the sine of 5x over x. And this thing is just equal to 1. So we get 5 times 1. So we're going to get 5 as our solution. Right? The easy way to do it is just be like, hey, it's a sine of 5x. It's a sine of x. It's going to be this 5. Like if I had like the limit as x approached 0 of the sine of like, I don't know, 1.694x over x, that limit's just going to be 1.694. It's just going to be that coefficient of x.